Hey guys, let's knock out this review real quick. I'll get you ready for test 25. Okay, so here we go. Number one, actually the first several are just exponential graphs. Number one, because it's a 3 right there, is exponential growth. There's no shift in it at all, so the asymptote is going to be the x-axis like we would expect. Remember, first point is going to be 1 above because 3 to the 0 power is 1. Let's go 1 to the right of that point and plug in 1. 3 to the first power is 3. I'm going to connect the dots right there. And there's your graph. I need to see those 2 points though on your graph. Number two, because it's a fraction, it's going to be exponential decay. So it's going to fall from left to right. Still no shift, so my asymptote is still there. Still a point there. If it's decay, you have two options. You can still go 1 to the right if you want to, and 1/3 to the first power is 1/3, so it's going to be there. But if it's decay, sometimes it's better to go 1 to the left, plug in -1, which means it's going to flip the 1/3 to +3, and it's just going to be the reflection of the first one. All right, number 3, 4 times e to the -x. Okay, here we go again. Still, there's your asymptote. Now, the 4 in the front means there's a vertical stretch, which means you multiply your y-coordinate by 4. So usually I'd go up 1, but this time I'm going to go up 4. And e, now, because there's a negative exponent, it really flips the e, which also makes it decay. So if I put in 1 to the right, which would be -1, I'm going to punch my calculator and hit 4. Let's see here. 4 times e to the -1 power. Let's see what I get. I get 1.47. So if I plug in 1, I'm getting 1.47, which is about right there. Remember, it's decay, so my graph's going to do this right here. And again, need to see your 2 points tomorrow. Number 4 has a -2. On the outside, the -2 is going to shift everything down 2, so it shifts my asymptote down 2. I'm going to go up 1 for my next point. I'm going to go 1 to the right. If I plug in 1 for x right there, I get 3 minus 2, which is 1, by the way. So if I plug in 1, I got 1. Need to see the 2 points, connect them. Got it. 5 and 6, more the same. Number 5 has the e has a x minus 3 in the exponent. All that does, it doesn't move the asymptote at all, still the same place. Usually I'd go up 1 right there, but the -3 means you got to go left to right, opposite of what you think. So I'm going right 3 to right there. Again, I'm going to plug in 1 to the right of that, which is 4. So I'm plugging in 4. And the e to the first power is 2.71828. So it's about right there. Need to see those 2 points. Connect the dots. You got it. Number 6, 2, I got everything in it. 2 times 4 to the x minus 1 power plus 3. That's actually starting here at the +3. The +3 is a vertical shift. We're going up 3. Usually from there, I would go up 1, but the 2 in the front, I'm going to multiply that 1. I'm going to go up 2 instead of just 1, so it puts me up at 5. But there's also a -1 in parentheses, which shifts it right 1. That was a lot for that first point. Let's go through one more time. Usually I go up 1 from the asymptote to 4, but the 2 means I multiply that 1 times 2, which is going to be, I'm going to go up 2 from the asymptote, and then the -1 is going to be a horizontal shift opposite of what you think, right 1. Now I'm going to plug in 1 to the right. I'm going to go 1 to the right, which puts me at 2. So I'm going to plug in 2 right there. If I plug in 2, the exponent becomes 1. So it's 2 times 4 plus 3. 2 times 4 is 8. 8 plus 3 is 11. So if I go to 2, 11's way up there somewhere. Going to connect those, exponential growth. Got it. Number 7, a review from a week or so ago. Fraction inequality. I've got to make it one fraction right here. So I'm going to multiply. Actually going to subtract. Remember, when we subtract, I gave you the good shortcut to do that. We're going to multiply your denominators, cross multiply here. That'd be x squared minus 1 minus, and I'm going to cross multiply there. Now I'm going to do FOIL. I'm going to save some time here and do FOIL in my head. I'm going to get x squared minus 5x plus 6 when I do FOIL. What's going to happen is my x squareds are gone. I'm gonna get a, oops, I'm going to get a positive 5x. That minus sign changes all those signs in parentheses, so it's 5x. 1 minus 7 is -7. I have x minus 2 and x minus 1. Now I can draw my sign graph. I'm going to have a, let's see, a 1, a 7/5, and a 2 on my sign graph. Plug in 100 everywhere. The top's going to be positive. The bottom's going to be positive and positive. So it's positive there, negative, positive, negative. Because I'm looking for less than 0, I'm looking for negative signs, which is the negative signs are from -infinity to -1. With the parentheses, and also 7/5 with the bracket because it's on the top. Oops, not to infinity, but to 2 with the parentheses because it's on the bottom. It's a pretty good one. Number 8, describe the end behavior. Okay, I'm looking at the degree, which is right there. Degree is 8. Even's both ends up or both ends down. Because it's negative, both ends down. Okay, you're just going to show me the little picture like that. Number 9. Suppose you invest $1,750 at 3.5% interest, compounded quarterly. How much you have after 8 years? Here we go. It's all calculated, but you got to set this thing up. P is principal. 1 plus R over N. The rate's 3.5%, so change it to a decimal. Over N. N is how many times you're compounding per year. Quarterly is 4 times a year. Your exponent's N times T, which is 4 times 8, which is really 32. So I'm going to punch that in real quick. And I'm getting, and you should get exactly the same thing. It may be a good idea for you to punch that in your calculator right now. Make sure you got the same thing I did, just to make sure you're punching it in the exact right way. Number 10. On Mark's 6th birthday, his grandparents give him a $5,000 CD that earns 6% interest compounded daily. If it matures on his 18th birthday, what amount will there be? Okay, so they want to know how much his $5,000 will be when he turns 18. Right now he's just 6, by the way. So that's 12 years. So 1 plus the rate is 6%. Over N, how many times is it compounded? Daily, 365 days in a year. My exponent is going to be 365 times the time. And he did 12 years. So again, I'm going to punch that in real quick and see what happens with his money. And luckily for Mark, his money more than doubled. I'm getting $10,271.56. Good gift from those grandparents. All right, number 11. Find each of the following. I wish you would do 11, 12, 13 without a calculator. All it's asking you here is 5 to what power is 125? What power did you raise 5 to get 125? The third power. This one, 3 to what power is the fifth root of 3? Remember, bottom is the root, top is the power, so that's a 1/5 power. And same thing here. That's really base E. E to what power is the square root of E? Again, bottom is the root, top is the power. The square root is 1/2 power. All right, 14 and 15 are straight up just punching your calculator. I'm hitting log 0.082 on the calc, getting negative 1.0862. And again, that's negative because that's a decimal in there. Had to flip the 10. Use the calculator to find natural log 50. If I hit natural log 50, getting 3.912. And we'll go 4 decimal places on those. 16, graph the log. And this is the last problem. So remember, log is the inverse of an exponent. Usually I would draw my asymptote on the y-axis. The -2 shifts everything to the right. So I'm going to go 2 to the right. There's the asymptote. First point's always 1 away from it. And then what I want to do for my second point is I always want to make whatever that comes after the base. I want that to make that the same as the base. So what am I going to put in for x to make that become log 3,3? Because everybody knows log 3,3 is 1. Well, the answer is 5. I got to put a 5 in for the x. So if I put in 5, that gives me log 3,3, which is 1. So the point I'm going to graph is 5, 1. Because I put in 5, I'm getting 1. There's that point. And I need to see both those points for sure. And there's your graph. All right. Hope that helps. Hope you do great tomorrow. See you then.